Hello, in this video I'll be working through Unit 3 homework problems 25 through 37, and these primarily deal with the quotient rule. Number 25 asks us to rewrite f of x as a polynomial first and then apply the power rule to find f prime of x. So to rewrite this as a polynomial, I'm going to take each term in the numerator and divide it by the denominator. So we can rewrite this as f of x equals, now 2x cubed divided by x squared is 2x. Negative 3x squared divided by x squared is negative 3. And 3 divided by x squared is 3x to the negative 2. Okay, so technically this isn't a polynomial because I have an exponent of negative 2, but it's in polynomial-like form. And so when it's in this polynomial-like form, we can find the derivative using the power rule. So f prime of x equals the derivative of 2x, which is 2, minus the derivative of 3, which is 0, plus the derivative of 3x to the power negative 2, which is negative 6x to the power negative 3, and we can simplify that as 2 minus 6 over x cubed. Number 26, apply the quotient rule to f of x to find f prime of x. So this is the same function we saw in number 25, but now we're going to find the derivative using the quotient rule. So f prime of x equals the derivative of the top, which is 6x squared minus 6x, so that's derivative of the top, times the bottom, minus the top, 2x cubed minus 3x squared plus 3, times the derivative of the bottom, so times 2x, all of that over the bottom squared. Now if we simplify this, it should give us the same result we got in number 25. So I'm going to distribute my x squared and get 6x to the power 4 minus 6x to the power 3. And then I'm going to distribute this 2x and distribute the negative. So we got a lot going on here. Okay, so 2x cubed times 2x is 4x to the fourth times negative 1. It's negative 4x to the fourth. And then 2x times negative 3x squared is negative 6x cubed times negative 1 is positive 6x cubed. 2x times 3 is 6x times the negative 1 is minus 6x. And all of that is over x to the power 4. Okay, so my like terms here, 6x to the fourth minus 4x to the fourth, that's 2x to the fourth. And then I've got minus 6x cubed plus 6x cubed, that's just 0. And minus 6x all over x to the power 4. Now 2x to the power 4 divided by x to the 4 is 2, minus, and then 6x over x to the fourth is 6 over x cubed. So we get 2 minus 6 over x cubed. Number 27, find the equation of the line tangent to the graph of g of x when x is negative 1. So to find the equation of the tangent line, I need to know g of negative 1 to get my point of tangency, and then I need to know g prime of negative 1. So let's find g of negative 1 first, and for that I'm just substituting negative 1 in for x into the function g of x. So 2 times negative 1 squared minus 3 times negative 1 over 3 times negative 1 plus 1. So that's going to give us 2 plus 3 is 5 over negative 3 plus 1 is negative 2, or negative 5 over 2. So now I know my point of tangency is negative 1 comma negative 5 over 2. Now before I find g prime of negative 1, I want to find g prime of x. And to find g prime of x, I'm going to use the quotient rule. So I need the derivative of the top, is 4x minus 3, times the bottom, 3x plus 1, minus minus top, so 2x squared minus 3x, times the derivative of the bottom, which is just 3, and all of that over the bottom squared. Now I could simplify this, but ultimately I just need to know what is g prime of negative 1. So I think I'm going to go ahead and substitute the negative 1 in now and simplify it after I have just constants in the expression. So 4 times negative 1 minus 3, that's negative 7. And then 3 times negative 1 plus 1, that's negative 2, minus 2 times negative 1 squared is 2, minus 3 times negative 1, so that becomes 2 plus 3, or 5, times 3, over 3 times negative 1 plus 1 is negative 2, and I'm going to square that to get 4. So this gives 14 minus 15 over 4, or negative 1/4. That's the slope of my tangent line. So I have point of tangency, negative 1 comma negative 5 over 2, and the slope of my tangent line is negative 1/4. So now I can write the equation of my tangent line. It's y plus 5 over 2 equals negative 1/4 times x plus 1. Number 28, find h prime of x if h of x equals x over the quantity x squared plus 1. So we will use the quotient rule. I need derivative of the top, which is 1, times the bottom, minus the top, times the derivative of the bottom, all over bottom squared. If we simplify that, we get x squared plus 1 minus 2x squared over bottom squared. And x squared minus 2x squared is negative x squared, so I get 1 minus x squared over x squared plus 1 squared. (29) Find dy dx for y equals x over the square root of x plus 1. So dy dx, it's just a different notation for our derivative. I'm going to use the quotient rule. It's derivative of the top, which is 1, times the bottom, the square root of x plus 1, minus the top times the derivative of the bottom. The derivative of square root of x is 1 over 2 root x, and the derivative of 1 is 0. So all of this is over the bottom squared. Okay, and if we simplify our top, we get square root of x plus 1 minus, now x over 2 root x is square root of x over 2. And all of this is over square root of x plus 1 squared. Okay, now to simplify this further, to get rid of that complex fraction, I'm going to multiply the outer fraction by 2 over 2. So I'm going to distribute this here. Now the square root of x and negative square root of x over 2 are like terms, but I think I'll wait and combine them after I do this multiplying through by 2. So 2 times square root of x is 2 root x, plus 2 times 1 is 2, minus 2 times square root of x over 2 is just minus square root x, and this is over 2 times square root x plus 1 squared. So on the top, we've got some like terms here that we can combine, so we just get square root of x plus 2 over 2 times square root of x plus 1 squared. Number 30, find g prime of theta for g of theta equals cosine theta over theta cubed. G prime of theta, we're using quotient rule, so we have derivative of the top, derivative of cosine theta is negative sine theta, times the bottom, so this is going to be multiplied by theta cubed, minus the top, so cosine theta, times the derivative of the bottom. The derivative of theta cubed is 3 theta squared. All of this is over bottom squared, so theta cubed squared is theta to the power 6. Now there's not much I can do in terms of simplifying here. I could factor out a theta squared. Let's go ahead and do that. I'm going to also, I'm thinking about factoring out a -1. I'm going to go ahead and factor out negative theta squared from the top. So that's going to leave theta sine theta plus 3 cosine theta over theta to the power 6. And then theta squared over theta to the power 6, we can simplify that. So we get negative theta sine theta plus 3 cosine theta over theta to the power 4. Number 31, find dy d theta for y equals 3 times 1 minus sine theta over 2 cosine theta. So dy d theta, we're going to use the quotient rule to find dy d theta. So I want derivative of the top. For the derivative of the top, I'm going to use my constant multiple rule. So it's 3 times the derivative of 1 minus sine theta. The derivative of 1 is 0. The derivative of minus sine theta is minus cosine theta. So 3 times negative cosine theta gives us negative 3 cosine theta. That's the derivative of the top. That's going to get multiplied by the bottom. So we're going to multiply by 2 cosine theta minus the top, 3 times 1 minus sine theta, times the derivative of the bottom. Now on the bottom we have 2 cosine theta. The derivative of 2 cosine theta is 2 negative 2 sine theta. So there's my 2 sine theta, and then my negative I'm going to bring to the front. The double negative will become positive. And this is all over the bottom squared, so 4 cosine squared theta. Now let's see how we can simplify the top. So we've got negative 3 times 2 is negative 6. Cosine theta times cosine theta is cosine squared theta. Okay, and then we have, I guess we can distribute this here, and then also distribute the 3 here and here. So the 2 sine theta multiplied by the 1 is 2 sine theta, multiplied by the 3 is 6 sine theta. And then I have 2 sine theta times negative sine theta, so that's negative 2 sine squared theta, times the 3 is negative 6 sine squared theta, all over 4 cosine squared theta. Now we can factor a 2 from the numerator and a 2 from the denominator. And I can do a little bit with this right here as well. I've got negative 6 cosine squared theta minus 6 sine squared theta. So let's factor out a negative 6 from the numerator so we can see how we can use the Pythagorean identity here. So if I factor out a negative 6, I'm left on the top with cosine squared theta minus sine theta plus sine squared theta. And this cosine squared theta plus sine squared theta becomes 1. Okay, so then the negative 6 over 4 reduces to negative 3 over 2. The cosine squared theta plus sine squared theta becomes 1. So 1 minus sine theta. And then on the bottom, a 2, because remember we had 6 over 4, but now it's 3 over 2, cosine squared theta. (32) Let f and g be differentiable functions for which the following information is known. F of 2 equals 5, g of 2 is negative 3, f prime of 2 is negative 1/2, and g prime of 2 is 2. Let r be the function defined by r of x equals g of x over f of x. Is r increasing, decreasing, or neither at a equals 2? So in order to answer this question, we're going to want to know if our derivative of r is positive, negative, 0, or undefined. So we'll start by finding r prime of x. So here's my rule for r of x. To find r prime of x, we're going to use the quotient rule. So derivative of the top would be g prime x times the bottom, f of x, minus the top, g of x, times the derivative of the bottom, f prime x, over bottom squared, f of x squared. At a equals 2, so now let's find r prime of 2. We have g prime of 2 times f of 2 minus g of 2 times f prime of 2 over f of 2 squared. The g prime of 2 is given as 2, so we have 2 times f of 2 is 5 minus g of 2 is negative 3. F prime of 2 is negative 1/2 over f of 2 is 5 squared is 25. So this is 10 minus 3/2 over 25. So 10 minus 1.5 is 8.5. Divided by 25 is positive. So I'm not really concerned about what this value is equal to. I just wanted to know if it's positive, negative, 0, or undefined. And it is positive, therefore we know r is increasing. So r is increasing at a equals 2, since r prime of 2 is greater than 0. Part B, estimate the value of r of 2.06 by using the local linearization of p at the point 2, p of 2. So we are actually going to have to calculate r prime of 2 because that's going to give us the slope of our tangent line. So let's go ahead and compute that. So 10 minus 3 over 2. 10 is 20 over 2 minus 3 over 2. That's 17 over 2. So I have 17 over 2 over 25. So the over 25 is just going to put the 25 in the denominator. So it gets 17 over 50. That's going to be the slope of my tangent line. So r prime of 2 equals 17 over 50. Next, we'll find the point of tangent C. So for that, we need to find r of 2. And I just noticed here we have a typo. It says p and p of 2. That should be r, actually, and r of 2. Okay, so r of 2, we're going to go to our equation for r of x and substitute in a 2. r of 2 equals g of 2 over f of 2. So g of 2 is negative 3, and f of 2 is 5. So the point of tangent C is 2, negative 3/5. And that means my equation for my tangent line is y plus 3 over 5 equals negative 3/5 times x minus 2. Since we're asked to use the local linearization, I'm going to use that other notation. L of x equals, so instead of the y plus 3 over 5, now we're subtracting that 3 over 5, so we get negative 3 over 5 plus my slope, 17 over 50, times x minus the x-coordinate at my point of tangent C. And then r of 2.06 is going to be approximately equal to L of 2.06. So that's going to be negative 3 over 5 plus 17 over 50 times 2.06 minus 2. And we can compute that on our calculator. We get negative 0.5796. So that will be our approximation for r of 2.06. 33. Consider the functions r of t and s of t. r of t is t to the power t. S of t is arc cosine t, for which you're given the facts that r prime of t equals t to the t times ln t plus 1, and s prime of t is negative 1 over the square root of 1 minus t squared. We restrict our interest in both functions to the domain strictly between 0 and 1. Let v of t be the quotient t to the t over arc cosine t. So v equals r of t over S of t. Is v increasing or decreasing at the instant t equals 1/2? So in order to answer that question, we want to know if the derivative of v is positive, negative, 0, or undefined when t is 1/2. So we'll start by finding our derivative. V prime of t equals, we're going to use the quotient rule, so derivative of the top, and that's given to us. As r prime of t equals t to the t times ln t plus 1. So derivative of the top times the bottom, so times arc cosine t, minus the top, t to the t, times the derivative of the bottom, and the derivative of the bottom is given to us as negative 1 over square root of 1 minus t squared. All of that gets divided by bottom squared. So arc cosine of t squared. Now I want to know, what is v prime of 1/2? So that's going to be 1/2 to the power 1/2 times natural log of 1/2 plus 1 times the arc cosine of 1/2 minus 1/2 to the power 1/2 times negative 1 over square root of 1 minus 1/2 squared is 1/4. And then that all gets divided by arc cosine of 1/2 squared. And there we should be getting 1.0437, which is positive. So now since v prime of 1/2 is greater than 0, v is increasing at t equals 1/2. 34. Let functions p and q be the piecewise linear functions given by their respective graphs below. Z equals p over q. Determine z prime of 0 and z prime of 2. Okay, so first of all, we need to find z prime of x. Z prime of x equals, and we'll use the quotient rule here, it's derivative of the top, so p prime of x times the bottom, q of x, minus the top, p of x, times derivative of the bottom, q of x, q prime of x, over bottom squared, so q of x squared. Z prime of 0, we just need to substitute 0 in for x. So that's going to be p prime of 0 times q of 0 minus p of 0, q prime 0, over q of 0 squared. P prime of 0, so looking at the graph of p, when x is 0, the slope at that point is 1/2, times q of 0, so looking at the graph of q, the purple one, when x is 0, q is 2, minus p of 0, so looking at the yellow graph of p, when x is 0, the function value is negative 1/2, times q prime. So at 0, what is the derivative of q? That derivative is 0, over q of 0. So q of 0, the purple graph, at 0, the function value is 2. We're going to square that and get 4. Okay, so we have 1/2 times 2 is 1, minus 0 over 4, or 1/4. Z prime of 2 will be p prime of 2. So p prime of 2 is the slope of p when x is 2, and that slope is 2, times q of 2. So the value of q when x is 2 is 1, minus p of 2. So the value of p at 2 is 2, times q prime of 2. The slope of q when x is 2 is negative 1. Over q of 2, so q of 2, purple graph at 2 is 1, and we're going to square that. So we get 2 plus 2 over 1 is 4. Part B, are there values of x for which z prime does not exist? If so, which values and why? Well, let's look at our equation for z prime of x. So the derivative is not going to exist wherever p prime doesn't exist or q prime doesn't exist. So let's just break this down. Wherever p prime of x doesn't exist, then z prime won't exist. And p prime does not exist at these corner points where x is 1 or negative 1. So x equals 1, x equals negative 1. Those are corner points. P doesn't exist, P prime doesn't exist, therefore z prime won't exist. And then here as well, wherever q prime does not exist, z prime will not exist, and q prime does not exist at these corner points, which also happen to be at x values of 1 and negative 1. And there's one more place where z prime will not exist, and that's when we're dividing by 0. So wherever q is equal to 0, z prime is not going to exist. And q is equal to 0 at where the x-intercepts are. So we've got one right here, q equals 0 at x equals 3. And then q is also equal to 0 at this x-intercept over here. It's not a whole number. It looks like it's approximately negative 1.7, I'm going to say. Negative 1.7. 35. Use the table below to answer the following questions. If h equals 2 times f divided by g, what is the equation of the tangent line when x equals negative 1? So we're going to have to find h of negative 1. And we're going to have to find h prime of negative 1. Let's find h of negative 1 first. H of negative 1 is 2 times f of negative 1 over g of negative 1. So that's 2 times, and then f of negative 1 is 3 over g of negative 1. G of negative 1 is 1. So that's just 6. This is going to give us our point of tangency at negative 1 comma 6. Next, we need to find h prime of negative 1. So first we find h prime of x, and to do that, we're going to take the derivative of h using the quotient rule. So derivative of the top will be 2f prime x times the bottom, g of x, minus the top, 2f of x, times the derivative of the bottom, g prime of x, all over bottom squared, so g of x squared. Now we can find h prime of negative 1 by substituting negative 1 in for x. So 2 f prime of negative 1, g of negative 1, minus 2 f of negative 1, g prime of negative 1, over g of negative 1 squared. Okay, so 2 times f prime of negative 1 is negative 2, times g of negative 1, g of negative 1 is 1, minus 2 times f of negative 1 is 3, times g prime of negative 1, g prime of negative 1 is 1, over g of negative 1 is 1, so 1 squared, that's easy. So simplifying on the top, we have negative 4 minus 6 is negative 10 over 1 is just negative 10. So that is the slope of my tangent line. And the equation of my tangent line then is y minus 6 equals negative 10 times x plus 1. Part B, if j equals 3x plus cosine x over f of x, what's the value of j prime of 0? So first we'll find j prime of x using the quotient rule. Derivative of the top is 3 minus sine x times the bottom, f of x, minus the top, 3x plus cosine x, times derivative of the bottom, f prime x, all over bottom squared, so f of x squared. Then j prime of 0, we're going to substitute in 0. So we have 3 minus the sine of 0. The sine of 0 is 0, times f of 0, minus 3 times 0 is 0, plus cosine 0, the cosine of 0 is 1, times f prime of 0, all over f of 0 squared. Now let's go to the table. So we have 3 times f of 0. F of 0 is negative 1. So 3 times negative 1 minus 1 times f prime of 0. F prime of 0 is 2 over f of 0 squared. F of 0 is negative 1. So negative 1 squared is just 1. So we get in the top, negative 3 minus 2 is negative 5 over 1. So j prime of 0 equals negative 5. And part C, if k of x equals 4x plus f of x over 3 minus g of x, what is the slope of the normal line when x equals negative 2? So let's find our derivative. K prime x equals derivative of the top, so 4 plus f prime x, times the bottom, 3 minus g of x, minus the top, 4x plus f of x, times the derivative of the bottom, which will be negative g prime x, over bottom squared, 3 minus g of x squared. So when x is negative 2, our derivative is k prime of negative 2. And for that, we're going to have 4 plus f prime of negative 2 times 3 minus g of negative 2 minus 4 times negative 2 is negative 8 plus f of negative 2 times negative, so I'm going to go ahead and make this double negative here a positive, g prime of negative 2 over 3 minus g of negative 2 squared. So that's going to equal 4 plus f prime of negative 2 is negative 1. So 4 minus 1 times 3 minus g of negative 2. G of negative 2 is 2 plus negative 8 plus f of negative 2. F of negative 2 is 1, so negative 8 plus 1 times g prime of negative 2. G prime of negative 2 is 4 over 3 minus g of negative 2. G of negative 2 is 2, and that quantity squared. Okay, so this is 4 minus 1 is 3. 3 minus 2 is 1, so 3 times 1 is 3, plus negative 8 plus 1 is negative 7. Negative 7 times 4 is negative 28. And then over 1. So this is negative 25. That gives us the negative 25 is the slope of our tangent line. We're asked to find the slope of the normal line. So we want to use the opposite reciprocal. So the slope of our normal line will be positive 1 over 25. 36. If f of theta equals negative cosecant theta minus sine theta, show that f prime theta equals cotan squared theta cosine theta. Now, if you've memorized the derivative of cosecant theta, this would be a shorter problem for you. If you've not memorized the derivative of cosecant theta, we can still get it using the quotient rule. So first, let's rewrite f of theta as negative. Instead of cosecant theta, we'll write that as 1 over sine theta, and then minus sine theta. So I'm going to find my derivative, f prime of theta equals, and for this first term, I'm going to use the quotient rule. So the derivative of the top is 0. 0 times the bottom, sine theta, minus the top, so positive 1, times the derivative of the bottom, and the bottom is, the derivative of sine theta is cosine theta, over bottom squared, sine squared theta. So 0 times sine theta, that's just going to be 0, and that's all going to drop out. Now we move on to our next term. So minus the derivative of sine theta is cosine theta. Okay, so here we have cosine theta over sine squared theta minus cosine theta. And I want to combine these into a single fraction, so I'm going to multiply cosine theta by sine squared theta over sine squared theta, and now I can combine these. I get cosine theta minus cosine theta sine squared theta over sine squared theta. Now I'm going to factor a cosine from my numerator. So cosine theta times 1 minus sine squared theta over sine squared theta, and 1 minus sine squared theta equals cosine squared theta. So now this is cosine theta times cosine squared theta over sine squared theta. Cosine squared theta over sine squared theta is cotangent squared theta. So now I have cosine theta cotangent squared theta, which is what we were trying to show. Find the equation of the line tangent to the graph of f of theta equals tan theta sine theta when theta equals pi over 4. So we need to find f of pi over 4 and then f prime of pi over 4. F of pi over 4 is tangent pi over 4 times sine of pi over 4. Tangent of pi over 4 is 1. Sine of pi over 4 is 1 over root 2. So f of pi over 4 equals 1 over root 2, and that tells me my point of tangency is pi over 4 comma 1 over root 2. Now I need to find f prime of pi over 4. So first we find f prime of x. And to find f prime of x, I have some options. F is tan theta times sine theta, so I can use the product rule. Or I can write tangent as sine over cosine and use the quotient rule. Since we're practicing quotient rule today, let's do it that way. So I'm going to rewrite, maybe I'll just do it up here, f of theta equals, so if tangent is sine theta over cosine theta, I'm going to get sine squared theta over cosine theta. Now that I'm looking at that, I have changed my mind. I do not want to use quotient rule because that's going to involve also using the chain rule, which we're not quite ready for. So let's stick with product rule. We've got the first factor is tan theta and the second factor is sine theta. So derivative of the first, the derivative of tangent is secant squared theta. And if that's not one that you have memorized, you can find the derivative of tan theta using the quotient rule. If you write tan theta as sine theta over cosine theta, you can get the derivative using the quotient rule. But derivative of tan theta is secant squared theta, so that's derivative of the first, times the second, plus the first, times derivative of the second. And the derivative of sine theta is cosine theta. So there's my derivative. This is product rule, so we're not dividing by anything. And now I want to find f prime of pi over 4. So I need the secant of pi over 4. And then we're going to square that, times the sine of pi over 4, plus tangent pi over 4 times cosine pi over 4. Secant pi over 4 is just the reciprocal of cosine pi over 4. The cosine of pi over 4 is 1 over root 2. So the reciprocal of that would be root 2. And we're going to square that. So the square root of 2 squared is just 2. The sine of pi over 4 is 1 over root 2. Plus tangent of pi over 4 is 1. And then cosine of pi over 4 is 1 over root 2. So we have 2 over root 2 plus 1 over root 2. Those are like terms. So we can add the coefficients. We get 3 over root 2. Okay, so that is the slope of our tangent line. And our equation then will be y minus 1 over root 2 equals 3 over root 2 times x minus pi over 4.